Hi everyone. In today's quick video, I just want to explain some measurements that I've taken on a two-way loudspeaker, and a two-way loudspeaker that is where the high frequency and the low frequency driver is separate. So it's not a coaxial driver, they are separate. We have the loudspeaker that I was taking measurements of is a EAW RL15. So it has a 15-inch woofer and a 1.75-inch HF driver with a 1-inch exit. So they take up two separate spaces, physical spaces. So it's not a coaxial driver, they're two separate drivers. The HF has got a horn flare, and the horn flare has got a horizontal dispersion of 90 degrees and a vertical dispersion of 60 degrees. Now the alignment between these two is done with the EAW focusing, which is FIR filtering, so they can reproduce the crossover and the alignment so that you get a linear response in the phase response. So phase linearity, you'll see here, is quite flat. So usually in the crossover region you will see a phase wrap due to the high pass and the low pass filters if it is standard IIR filtering, but because it's FIR filtering you get a linear phase response. So the crossover is roughly around 1.2 kilohertz. You can see here by the green and the black trace where the crossover is happening. And for the sake of this measurement I was using the main setting, so just the full range setting, and that's the green response over here in the trace. So let's have a look at the video, and then we will I'll make some commentary during the video as we watch it. So here I'm capturing the on-axis response as the speaker would normally be playing. You'll notice here that I've turned the speaker upside down so the horn is on the floor. This was just to get a good magnitude trace so that I could have a good reference to start off with without minimal reflections. So now I'm turning the speaker out towards the extremity of the 90 degrees on the horizontal, and you can see that the high frequency is dropping off. I wasn't quite happy with this, so I kept on turning it a bit just to get a better drop off on the high frequency response. So the microphone is as close to the floor as I could get it without touching the floor, just to get in line with the high frequency driver. You'll see there that the response that I took of the on-axis, the phase response isn't quite matching up. That was just because I was walking in front of the microphone, but I'm more interested in the crossover region around the 1.2 kilohertz. So now I'm turning the speaker on its side. So this is to emulate if you were to be looking at the phase response in the crossover region on a vertical plane, so above and below the speaker if it was hanging right side up. Wasn't happy with the magnitude response, so I moved the speaker more in line with the horn to match the horizontal plane of the loudspeaker. So now the magnitude response is lining up quite nicely with between the vertical and the horizontal. So now I'm going to be turning the loudspeaker to show you the response if you were underneath the vertical dispersion. So this being a 60 degree, I've gone a bit beyond that. You'll see how the phase response in the crossover region shifts. We are closer to the low frequency driver further away from the high frequency driver, and we can see that in the phase response where the low frequency is leading compared to the high frequency. Just shifting it more so that the microphone is more in line with the HF driver, similar to what I had it on the on axis. So we can see that there's between a 6 and 9 decibel drop in the high frequency, so we are out of the high frequency coverage, and we can clearly see that shift in the crossover region between the low and the high. So now I'm turning it around to emulate the response if we were above the loudspeaker. So we can see how that frequency response also drops to a 6 to 9 decibel in the high frequency. Now we can see that the high frequency is closer, so that is leading compared to the low frequency driver and that phase wrap in the crossover region. See the comparison between the two, between the above and the below. So this was quite a nice exercise. Just to wrap it up, take this into consideration when you are using point source loudspeakers and the aiming of them on the vertical plane. So thanks for watching.